To be farsighted or nearsighted. If you're nearsighted, like yours truly, your focal point is close and you're able to see things clearly close to you, but distance vision is blurry, and so you need correction to focus the light accurately onto the retina. If you're farsighted, your distance vision is clear, and likely if you're a young person that your reading vision is also clear, so you're that person walking around without glasses whatsoever, so lucky you. Now let's get to the science behind it a little bit. So this is your eye here. Light is entering through the cornea. It travels through the pupil, through a few other structures, and then hopefully is focused accurately in a pinpoint fashion on the retina to provide clear vision. So if we look at a cross-section of the eye, and I apologize, it's not the greatest artistry work here. It's here. So if you look at the eye structure here, light is passing through the cornea, and we're assuming a very distant target, which is at optical infinity, and parallel light rays are entering the eye. So if we assume that light is coming in and it passes through the cornea, the lens, and it's beginning to be focused towards the retina here. Now we hope that it focuses right on the retina and we have a very clear image provided back to the brain. Now in some instances, usually because the eye is actually slightly, and it's fractions of millimeters, but slightly elongated, and that can be for a variety of reasons. Usually genetics plays a part, but a nearsighted eye is technically a little bit of a longer eye. So the structures in the front of the eye are focusing light here. Now that happens to be focusing right at a location that's actually in front of the retina. So by the time that light reaches the retina, it is not a pinpoint image and it is not clear. So in this situation, you need to provide correction either with a contact lens or a spectacle lens. In this situation, you would actually want to use a minus lens. So in my case, it's a minus lens, which actually will diverge first this parallel light. So the light is actually diverging as it enters the eye, and now these powerful structures will diverge the light, and now it's coming from here. So now when it is converged, the light is now focused right on the retina. Sorry for that. Right on the retina. Now you're seeing clearly. So if you're farsighted, if you're very farsighted, you're likely dealing with the opposite, where you need a plus lens to focus the light. But other times, if it's a small amount of farsightedness, it doesn't need to be corrected, and you're seeing clearly. So hopefully you followed that. Hopefully that explains it. So there you go.